Welcome to the Deep Dive. Today, we're really digging into the incredible story of farming technology.
Yeah, it's a fascinating journey.
From the absolute basics, the earliest tools, right up to the super advanced machines shaping how we get our food today.
Absolutely. From hand tools to AI.
We've got a great stack of material here. We're looking at everything from, like, early settlements, Catalhuyuk,
Mm,
all the way through to, well, autonomous tractors.
it's quite the leap.
Our goal is to really get a feel for the ingenuity behind it all and, how these developments fundamentally changed, well, everything, human civilization.
It's hard to overstate the impact, really. Okay, so where do we start?
Okay, let's unpack this, maybe start right at the beginning. Pre-mechanization.
Right. It's remarkable when you think about it. For most of human history, feeding ourselves depended on really, really simple innovations.
Like what? Digging sticks.
Exactly. Digging sticks, hand hoes, basically just extensions of our own hands and effort.
But they were revolutionary then, weren't they?
Yeah. Oh, completely. They allow people to shift from being nomadic hunter-gatherers to actually settling down, cultivating land. A total change in lifestyle.
Yeah, our sources point to some amazing early examples, like Catalhuyuk.
Ah, yes, in modern-day Turkey, around 6000 BC.
Right, and they were using something called slash and burn agriculture,
Mm-mm. You cut down vegetation, then burn it.
which clears the land, obviously, but the ashes.
The ashes act as a fertilizer. It's
Oh.
actually quite an effective way to enrich the soil, especially in those early days.
Clever. And what were they growing? The sources mention wheat, barley.
Peas, yeah, even berries, possibly for wine, and nuts for oil.
Yeah.
A decent variety.
And planting. How do they actually do that?
Likely all by hand, using those sticks and hoes to sort of scratch up the soil, turn it over a bit, and then just scattering the seeds.
Pretty labor intensive.
Very. But it worked. And what's interesting about Catalhuyuk, too, is they seem to have had some early understanding of water management.
Irrigation. That early.
Not complex systems, no, but basic techniques to supplement the rainfall. It shows they were already thinking about how to make sure the crops got enough water.
That's pretty advanced thinking for 6000 BC.
It is. And their harvesting tool, sickles made from obsidian.
Obsidian, like volcanic glass.
Exactly. And apparently it could be flaked to an edge sharper than early steel.
Wow. So a really smart use of the materials they had available.
Definitely. Okay, so let's move forward a bit, maybe to Mesopotamia. Around 5000 BC, that's where we start seeing the first hints of the plow.
Okay, the plow. But these weren't like big wooden things pulled by oxen yet, were they?
No, not at all. Initially, they were really just forked sticks. The idea was just to scratch a trench in the soil to drop the seeds into.
So not turning the soil over deeply, just making a line.
Precisely. But it was a step up from just using a hand hoe. It meant you could prepare more land a bit faster. Though, how well it worked would depend a lot on the climate and soil.
Still a fundamental shift, right? The potential to grow more food.
A huge conceptual leap. And then comes the next big thing, domestication of animals for draft power.
Oxen. Around 4000 BC, the sources mention, in the Indus Valley.
Right. And that was a real game changer. Suddenly, you've got serious muscle power to pull these early plows.
Which makes the whole process much faster, much more effective.
Exactly. And by about 1500 BC, we see wooden plows drawn by animals becoming pretty much the standard. Some of the earliest actual examples are from ancient Sumeria.
So that transition from human power to animal power, that marks a really significant jump in potential food production.
A massive jump. It scales everything up.
And Mesopotamia kept innovating, didn't they? The seed plow, around 2300 BC.
Ah, the seed plow. Yes, that's a fantastic piece of early engineering.
So what was it exactly?
Basically, they attached a sort of funnel to the plow. As the plow made the furrow, seeds from the funnel would drop directly into it.
Whoa, so plowing and planting all in one go.
Pretty much. Talk about efficiency. It sped up planting enormously and probably made sure the seeds were placed much better than just scattering them. Early precision agriculture, almost.
That's incredible for that time period. And what about harvesting all this extra grain? You needed better tools for that too, I guess.
You did, and that's where sickles come in again. Developing around the same time as these early plows.
Stone sickles initially.
Right. Flint or other stone blades attached to handles made of wood or bone.
And that made a big difference compared to just pulling grain by hand.
Oh, absolutely. It dramatically increased how much grain one person could harvest. This was essential for making grain agriculture really viable on a larger scale. You could actually gather the surplus.
And later they moved to metal, copper, bronze.
Yeah, as metalworking developed, they started making sickle blades out of copper, then bronze. More durable, probably held an edge better.
Okay, this next bit is really cool. The discovery in Switzerland,
Ah, yes, son. Very significant find.
dating back, what, 5,100 to 4,700 years ago? Europe's oldest plow marks.
That's right. And what's crucial is how they were preserved, covered quickly by stream sediments.
So you can actually see the marks?
You can see the parallel furrows, yes, and even hoof prints alongside them.
Hoof prints. So that's concrete proof of animals pulling the plows.
Exactly. It's the first really solid archaeological evidence for widespread animal-drawn plow agriculture in prehistoric Europe, and it's much earlier than we previously thought.
How much earlier?
Well, the previous best evidence was maybe 1,000 years younger, from places like northern Germany and Denmark.
So this Swiss find really pushes back our understanding of how farming, proper field farming, spread in Europe.
It does. It suggests that using animals, likely domesticated cattle or oxen, to pull plows wasn't some later refinement in Europe. It was probably part of the package, part of how Neolithic farming initially spread across the continent.
And you can see how that would be transformative. Plowing larger fields with animals, massive productivity boost.
Huge impact. It potentially changes everything: settlement sizes, social structures, the whole 9 yards.
Okay, let's shift focus a bit. Ancient Egypt, agriculture that was all about the Nile, right?
Completely centered on the Nile Valley and that annual flood, the inundation.
So they used plows too.
Yes, wooden plows, sometimes with metal bits for reinforcement, pulled by oxen. Very similar in principle to Mesopotamia.
And hoes and sickles as well, I assume. Flint sickles again.
Yep, those essential tools were definitely there. But Egypt's real genius was in water management.
Because of the flood.
Exactly. They developed basin irrigation using dikes, canals, reservoirs to trap and distribute the floodwaters effectively.
And the shadoof, that came later, around 1500 BCE.
Right, the shadoof, that counterweighted lever device. It was a really clever, low-tech way to lift water from the river or canals into fields that were a bit higher up, made irrigation much more efficient.
Their whole society was built around managing that river cycle, wasn't it?
Absolutely. Their calendar, their economy, their religion, it was all deeply tied to the rhythms of the Nile and the agriculture it enabled. That food surplus was the foundation of everything.
It's amazing.
Yeah.
And it wasn't just these huge empires making progress.
Yeah.
Our sources mention Scandinavia too.
Yeah, the National Museum of Denmark material. It shows that the first farmers who arrived there, south of the Baltic,
They brought the whole toolkit with them.
pretty much. The knowledge of how to clear forests using these polished flint axes they call point-butted.
Okay.
They had sickles, again with flint blades, for harvesting grain. They had saddle querns,
What are those?
big sort of trough-shaped stones used with a smaller rubbing stone to grind grain into flour, usually granite.
Ah, right, for making bread.
Exactly. They even found circular clay discs, likely used for baking flatbread. It shows how this basic agricultural package, the tools and the techniques, spread with the people.
So across different regions, different cultures, you see these core ideas taking root. Clearing land, planting, harvesting, processing grain.
Definitely. It illustrates that spread of knowledge, adapting the core ideas to local conditions, local materials. These tools seem simple now, but they were the bedrock. Everything else builds on this.
Okay, so that takes us through a long period of, let's call it, human and animal-powered farming. Then we hit the 18th century, and things start to shift. Mechanization begins.
Right, a definite acceleration. You start seeing more machinery and, crucially, more use of metal.
Cast iron, specifically.
Yeah.
That first patent for a cast iron plow in 1797.
Yeah, moving beyond just wood, or wood reinforced with a bit of metal. Cast iron is stronger, lasts longer, especially in tougher soils.
And another key thing from that period, replacement parts.
Seems minor, doesn't it? But it's huge.
Why is it so important?
Well, before that, if a key part of your wooden plow broke, you might have to replace the whole thing or find a skilled craftsman for a complex repair. With standardized metal parts, you could just swap out the broken piece.
Ah, makes maintaining the equipment much easier and cheaper in the long run.
Exactly. It makes owning and using these slightly more complex tools much more practical for the average farmer.
And right at the start of that century, 1701, we get a really pivotal invention, Jethro Tull's seed drill.
Ah, yes. Tull's drill. A major leap.
Why was it such a big deal? It wasn't the first attempt at a planting machine, was it?
No, but it was arguably the first really successful and influential one. And it was clever because it combined multiple steps.
Right, it had a small plow part to make the row,
Then a hopper for the seeds, a funnel to drop them accurately into the row.
and a harrow at the back to cover them up, all in one machine.
Exactly, pulled by a horse, or maybe even by hand on smaller plots. It was just much more precise than scattering seed broadcast style.
So, less wasted seed, better spacing, better results.
Generally, yes. Better germination, potentially higher yields, and faster planting. It really foreshadows that whole trend in agricultural machinery, integrating multiple jobs into one piece of equipment.
A key step towards modern farming, then.
Definitely a key step. Okay, so moving into the 19th century, things really pick up pace.
Yeah, this is where we see the big power shift, isn't it? Away from animals.
Towards steam power initially.
And then later in the century, steam starts getting replaced by internal combustion engines.
Right, running on kerosene or gasoline. Lighter, more efficient, easier to manage than steam engines.
Steam power must have seemed incredible at first, though. So much power compared to horses or oxen.
Oh, absolutely. Tireless power. But steam engines were big, heavy, needed water, needed stoking, cumbersome.
So the internal combustion engine was the real breakthrough for making mechanical power portable and practical on the farm.
A crucial development. It opened the door to truly mobile, self-propelled farm machinery.
Let's talk about some specific inventions from this era. The cotton gin, 1794. Eli Whitney.
A huge one, especially for the American South.
What did it actually do?
It separated the cotton fibers from the seeds and hulls, specifically for short staple cotton, which was really hard to process by hand.
And before the gin, that separation was incredibly slow and labor-intensive.
Painstakingly slow. The gin made it vastly faster. You could process so much more cotton.
Which had massive economic effects, obviously. Made large-scale cotton farming much more profitable.
Absolutely. It's a prime example of how one relatively simple mechanical invention could completely reshape an agricultural economy.
Okay, then around 1834, we get the reapers. Hussey and McCormick are the key names there.
Right. These were horse-drawn machines designed to cut standing grain.
How did they work?
They had a cutting bar with blades that moved back and forth like modern hedge trimmers, driven by the machine's wheels, or sometimes a hand crank initially.
And this replaced hand harvesting with sickles or scythes?
Exactly. And the difference in speed was immense. One person with a horse and reaper could cut as much grain as many people working by hand.
So farmers could manage much bigger fields of wheat or barley.
Precisely. A huge step towards large-scale commercial grain farming. And it freed up a lot of labor that was previously needed just for the harvest.
What about steam engines on the farm, before tractors became common?
Well, early on in the 19th century, there were often portable engines. You'd haul them to where you needed them.
To power what?
Things like threshing machines. You'd run a belt from the steam engine's flywheel to the thresher to power it, separating the grain from the stalks.
Right. And later, steam traction engines, actual self-propelled steam engines.
Yeah, they developed those too. Big, powerful machines. They were sometimes used for plowing, but often indirectly.
How so?
They might have two engines, one at each end of the field, pulling a plow back and forth between them using strong wire cables. Cable plowing.
Wow, that sounds complicated.
It was. And the engines were heavy, prone to getting bogged down. They showed the potential of mechanical power for heavy field work, but they weren't the final answer. They were sort of a bridge technology.
A bridge to what? The gasoline tractor.
Exactly. The internal combustion engine tractor, the real turning point for mobile power on the farm.
And the first gasoline-powered one. John Froelich, 1892.
That's the one often cited as the first successful gasoline tractor. It could drive forwards and backwards.
But it took a while for tractors to really catch on, didn't it?
It did. Early ones weren't always reliable, but then you get companies seriously developing them. And then Henry Ford comes along.
Ah, the Fordson, 1917.
Right. Mass-produced, relatively affordable, pretty reliable for its time. The Fordson really helped popularize the tractor.
And from then on, the tractor just becomes central, the core machine.
Absolutely. Could pull implements like plows and cultivators, but it could also power other machines. It became the versatile workhorse of the farm, replacing animals.
So the 20th century arrives,
Yeah.
and the tractor is established. What happens next? More innovation, I assume?
A huge amount. Tractors get better, stronger, more efficient, more versatile.
Like diesel engines.
Yes, diesel power starts becoming common, more fuel efficient than gasoline, and the engines often lasted longer. Big advantage for heavy work.
And hydraulics. That sounds important.
Oh, massively important. Hydraulics use pressurized fluid to transmit power.
What does that let a tractor do?
It allows the tractor to easily lift and control heavy implements mounted on it, plows, planters, cultivators. Before hydraulics, lifting implements was often manual or used complex mechanical levers. Hydraulics made everything much smoother, more powerful, and easier to control.
It's okay. I see. Big improvement for the operator. And the PTO, power takeoff.
Right, the PTO shaft. It's basically a spline shaft, usually at the back of the tractor, that takes power directly from the tractor's engine and transmits it via a drive shaft to attached implements.
So the tractor isn't just pulling the machine, it's running it too.
Exactly. Things like mowers, bellers, sprayers, they need power to operate their mechanisms. The PTO provides that power directly from the tractor's engine. Hugely versatile.
And we also see a move from purely mechanical systems to more electrical components.
Yeah, starting systems, lighting, gauges, and eventually this paves the way for more sophisticated electronic controls later on.
And the combine harvester. That's another big 20th century invention. First one around 1935.
Hey, though self-propelled versions became more common later.
And it combines, what? Reaping and threshing.
Reaping, threshing, and winnowing, cleaning the grain from the chaff. All the steps of grain harvest basically rolled into one machine.
Another massive efficiency boost for grain farming.
Huge. One machine, one operator doing the work that previously took multiple steps and multiple machines or gangs of people. The 20th century really saw relentless progress in agricultural tech.
Each one of these things, diesel, hydraulics, PTO, the combine, just another leap in getting more done with less labor.
Driven by better engines, better materials, smarter engineering, it was a period of really rapid advancement.
Let's run through some of that tractor timeline specifically. It's pretty dense. After Froelich in 1892,
you get Hartpar in 1901, who actually coined the word tractor and made the first commercially successful one.
okay,
International Harvester forms soon after, a major player. Benjamin Holt develops the crawler tractor, the Caterpillar track system in 1904. Great for traction, less soil compaction.
right, tracks instead of wheels.
Yeah.
And four-wheel drive.
Massey Harris gets credit for the first successful four-wheel drive tractor around 1920 through buying another company, better traction again.
Then some iconic models appear. John Deere Model D in 1923, International Harvester Farmall.
Exactly. The Farmall was hugely influential, a row crop tractor designed for cultivating as well as plowing. Very versatile.
First diesel tractor, Italy, 1928.
That's right. And then a huge leap in usability. Pneumatic rubber tires in 1932.
Rubber tires. Why was that so significant?
Before that, tractors had steel wheels, often with lugs for grip. They were rough riding, damaging to roads, and compacted the soil. Rubber tires meant a smoother ride, better traction in many conditions, less soil compaction, and you could drive them on roads. Big improvement. Alice Chalmers and Firestone were pioneers there.
Makes sense. Okay, keep going. 1935.
International Harvester puts diesel engines into wheeled tractors. 1941, Minneapolis Moline makes the first factory-produced LPG tractor running on propane.
Different fuel options. And then a major milestone in 1954.
Tractors finally outnumber horses and mules on U.S. farms. The mechanization transition is largely complete in terms of primary power source.
Wow. The end of an era for animal power.
Definitely. Then more refinements. Steiger pioneers rear PTO on big articulated four-wheel drive tractors in '58 and also early electronic controls. Case introduces the first integrated tractor cab around 1960 for operator comfort and safety.
Cabs. That must have made a difference.
Huge difference. Protection from weather, dust, noise. Steiger had the first 4WD with an enclosed cab too. Then turbocharging.
Faster engines.
More power from the same size engine, basically. Alice Chalmers' D19 in '61 was the first mass-produced turbocharged diesel tractor.
Affordable four-wheel drive from Versatile in '66. Kubota enters the U.S. market in '69. Competition heats up.
Mergers, too. Case and International Harvester merge in '85 to form Case IH, more electronics. Massey Ferguson introduces electronic control for the three-point hitch lift in '86, becomes standard.
Caterpillar brings rubber tracks to tractors in '87, combining the benefits of tracks and tires somewhat.
Right. Less compaction than tires, faster than steel tracks. JCB in Great Britain brings out the Fast Track in '91, the first tractor with full suspension. Much better ride, especially at higher speeds.
Then things get really high-tech.
Yeah.
1992, RTK guidance debuts.
Real-time kinematic. Using GPS signals with a ground-based reference station to get centimeter-level accuracy for steering the tractor.
Centimeter level. Wow. Precision farming starts here.
This is a cornerstone of it, yes. followed quickly by the wider introduction of GPS and satellite tech in farming around 1994, auto steer, yield mapping.
More sophisticated controls, Fendt tractor management system in 2004, optimizing engine and ground speed.
And environmental concerns driving tech, too. In 2010, Case IH introduces the first tractor meeting the strict EPA Tier 4A emission standards for diesel engines.
So cleaning up the engines. And that brings us pretty much into the current era, right, the 21st century, automation and precision agriculture.
Exactly, building on that GPS and sensor technology.
So we've got GPS guidance as standard on many machines now for that precise operation.
Mm-hmm. Sensors everywhere, monitoring soil moisture, nutrient levels, checking weather conditions, even monitoring the health of individual plants.
Vision systems, what are they for?
Cameras and AI that can see what the tractor is doing, identify weeds, monitor crop growth, help guide autonomous operations.
Right, autonomous tractors. That's the big buzz now. John Deere announced one for production in 2022.
Yeah, tractors that can operate largely or even fully without a driver in the cab. Still early days for widespread adoption, but the technology is advancing rapidly.
And drones, where do they fit in?
Aerial drones are becoming common, used for surveying fields quickly, creating detailed maps, monitoring crop health from above, even targeted spraying of pesticides or fertilizer.
The Internet of Things, too, connecting equipment.
Yeah, tractors talking to planters, harvesters talking to grain carts, all sending data back to the farm office or the cloud for analysis, making decisions based on real-time information.
It all falls under that umbrella of precision agriculture, doesn't it? Using technology to manage resources super efficiently, optimize inputs, monitor crops very closely.
Exactly. The goal is to be more productive, more profitable, and crucially, more sustainable, using less water, less fertilizer, fewer pesticides, only where they're needed.
And we're even seeing electrification start to happen. Monarch Tractor's fully electric smart tractor in 2020, Solartrack with battery power, New Holland in 2023.
Yes, the move towards electric power is beginning, driven by environmental concerns and potential operating cost savings. Still challenges with battery life and power for the biggest machines, but it's definitely a direction things are heading.
So when we step back and look at this whole story, it's just incredible. From a pointed stick
To a GPS-guided, sensor-laden, potentially autonomous electric machine.
it really showcases human ingenuity, doesn't it? Constantly finding ways to address that fundamental need for food more efficiently.
Every era brought its breakthroughs, tools that reduced the sheer physical toil, increased how much one person could produce, and yeah, completely reshaped societies along the way.
Those early insights, understanding soil, managing water in places like Catalhuyuk or Egypt, they laid the foundation.
They did. And then the big power shifts animal, steam, internal combustion, each one multiplying productivity many times over.
And now we're in this digital, data-driven revolution. Precision, automation, sustainability seem to be the watchwords now.
It feels like another major turning point, the potential to analyze and manage farming operations with a level of detail that was unimaginable even, say, 20 or 30 years ago.
You can see how all this connects to the bigger picture, right? More food supports larger population.
Allows for specialization. People don't all have to be farmers. Cities can grow, economies can diversify. Agricultural technology underpins so much of societal development.
Yeah, every innovation rippled outwards. Okay, so that brings us to our final thought for the listener. Considering this incredible journey, especially the recent acceleration with digital tech, how might advancements in fields outside traditional engineering start playing a bigger role?
You mean like biotech, AI?
Exactly. Biotechnology, advanced artificial intelligence. Could they revolutionize food production even further in the next few decades?
It seems likely, doesn't it? AI analyzing vast data sets to optimize everything, biotech perhaps creating crops that need fewer inputs or are more resilient.
Could we be heading towards a future where farming is, I don't know, almost entirely automated, hyper-efficient? And if so, what does that mean for us, for our connection to the land, the food we eat?
That's a really profound question. What does farming look like when the farmer might be managing a fleet of robots from an office? What happens to rural communities? What's our relationship with food production then?
Definitely something to chew on. Thanks for taking this deep dive with us today.
My pleasure. Fascinating stuff.